Hello everyone, this is Akshat Kapoor switching PLM. Good morning, good afternoon or good evening depending on the time zone you're tuning in from. Hope you all continue to stay safe in these trying times. Thanks for joining me in this segment of the SE event 2020. As you would have learned in the opening session on switching, the networks need to move towards more automation, virtualization and programmability. That is the call to action today. In this section of the webinar, I'll share with you what we are doing in terms of programmability, automation on Ommni switches. So let's dive in. So first up is the AOS microservices. So before I go into any more details on what we are doing on the automation front and what we are doing with AOS microservices, I would first like to give you a refresher on this technology. If you remember, we discussed this briefly last year when we launched something called adaptive learning. This is the new name for adaptive learning, which is now called AOS microservices. The AOS microservices is basically a lightweight non-AOS framework which enables us to do switch to switch and switch to NMS communications. Okay, it's a publisher subscriber model in which each switch can subscribe to the communication coming from a centralized switch or a designated switch, which is called a broker. Now, how do we organize these communications? The communications can be organized in two steps. The first step is grouping the switches into a community. Okay, think of it something like what you see in SNMP communities. Okay, so community could be a set of switches which share something common in them. Okay, they could be an edge switch community, they could be community of same switch types, it could be anything. It depends on the end user use case. Okay, now within a community, how do we group the communication? Each switch need not send out all communication. Same way, each switch need not listen to all the communication. Okay, so within the switch, we organize these conversations into something called topics. Okay, so the switches only listen to what they are interested in publishing or what they are interested in listening to. Okay, so the first step in this is that you need to identify a designated switch, which is called a broker or a director, which can moderate this communication. So it's a typical publisher subscriber model where a switch publishes, the information goes to the broker, and the broker relays it to the rest of the switches which are subscribed in that community or onto that thread. Okay, there is an illustration on the right side. So this is a very basic illustration of showing that, for example, all the edge switches are being organized into a community, and similarly all the 6860 switch types have been organized into one thread. Okay, so we have a broker in the center, which is a 6860 switch, and you can see that the broker communication with the 6860E shown by the green arrow is on a different topic, whereas the broker communication with the 6560 switches is with a purple arrow. So each of those 6560 may not want to learn about what the communication is going on for the 6860 and vice versa. Okay. Now you may ask, why do we do this? Why do we need it for at all? Okay. This is basically provides an agile way of delivering microservices for customers in an AOS independent framework. Okay. Some of the services, as we will see later on in this presentation, are very basic. They are needed by customers and they are needed for at a very short notice. And in those cases, the customers need not wait for the next AOS release, or they need not wait for the next OV release for the functionality to be available to them. Okay, this is what we call something as network programming. So you can program a whole community, or you can program a subset within a community which is defined by a topic, using this method. And what we are doing with this is we are trying to develop this as a framework which is more automated, more robust, and our goal is to provide a DevOps-like environment ultimately for our customers so that they can develop these services themselves. So customers have a choice. They can develop it, their own apps, or we can develop it for them depending on our relationship and how we want to help the customers in those particular scenarios. Okay. So in this case, all the switches in the community have to be configured with the broker IP so they can talk to the broker switch. That configuration is available in amsbroker.cfg, and the URL for that file is in the presentation, so I need not read out to it for you. Similarly, the other information on what a switch needs to talk on which topic and the information about the community it needs to join, all those details are present in the syncagent.cfg. So the customers using these details can define the communities, they can define the topics, and they can define the broker IP, which switch they want to be the designated switch. All of this can be defined through this. Okay. The commands for this are bundled under something called App Manager, and we will talk about this also in a more detailed manner in some of our later slides. So this is how it works. A switch comes up, it reads the configuration from the syncagent.cfg, and it finds out what is the community it belongs to, what is the topic it needs to listen to or relay information on, and then it establishes a communication with broker, joins the community, and joins the topic. Now, before all this has to happen, the whole AMS infrastructure, the applications need to be launched on each and every switch. Okay. So this is obviously a cumbersome procedure. This is not something which we will call an automated way of doing things. So we will see in the next slide how we are helping to automate all of this. But before that, I would like to take a moment to give you an example of how this works for some of the currently supported apps that we have. For example, we received a request from a customer that, as you would know, the 6465, the power supplies, even the ALE supplied ones, they need to be configured on each and every switch. Yes. So in this case, now the customer has a challenge that the power supplies are not auto-recognized. And what the customer wanted to do was to be able to program all the power supplies for all 6465 switches. The good thing in this case was that all the power supplies were of the same type. Okay. So in this case, what we did was develop an app for the customer where they can configure the 6465 power supply for one of the switches. And with this app, that configuration can be sent to all the switches. Now, in this case, all the 6465 switches will be part of the same topic, and no other switch in that topic would be a non-6465, right? So it will be only a 6465 specific topic, and all the switches will be able to learn the power supply configuration this way. This is something which we could do in a pre-staging area very quickly without doing, without setting up Omni Vista or without setting up the whole thing. Okay. So now let's see what we are doing for automating this configuration for the AMS. Okay. So as we learned in the last slide, you need to launch the AMS infrastructure on each and every switch. In addition, you need to configure a broker IP address on all the switches for this to work. Now, as part of this automation, what we have done is that we are allowing the broker IP address to be sent through a DHCP VSO option defined under option number 43. So these are vendor specific options. The structure of this for option 43 you can see on your right side. So it has multiple things. It has a sub option number 140, which defines the broker IP address. Now this broker IP address could be a IPv4 address, it could be a IPv6 address, or it could even be the DNS name of that broker, okay, which we can resolve and find where the switches can resolve and find the broker. The number 141 is the value of the TCP port. The TCP port is basically on which the broker will listen to the communication from the clients. Now, in this case, if a customer wants to use this particular feature, what they can do is they can program the DHCP option, VSO option 43 in their DHCP server, where they can provide the broker address along with the port number they want to open in their network for this communication. Once this DHCP option is received by the switches, they will know where the broker is and what port they need to connect with the broker on. And once they have established communication with the broker, they will automatically launch the AMS specific applications on their respective switches. As with regards to the broker will match the IP that it received in the option 43 from the DHCP server, and it matches with its own IP, and if sees it's equal, so it understands that it is the broker, and it launches the broker specific functionalities on that switch. So all this is automated. Now how this is done in terms of launching of these applications is we use the existing AOS trap and event action framework to launch these modules. The UDP relay would raise the trap based on the parameters received in the DHCP VSO option 43. This trap is raised on every reload and whenever the IP from the DHCP server is renewed, or if there is a change in options, in terms of whether the port is changed, the TCP port is changed, or the IP address is changed, or something like that. So an example is shown at the bottom of the page. You can see the option 43. 140 option is IP address 10.10.0.1. Sub option for 141 is 5555, which is the port number. And we have another thing is we have an sub option 42, which we have left for future use. The future use could be we plan to automate this further by even sending out the community or the thread specific information here, where the switches will know automatically what the community or thread they need to subscribe to. Yes, it does involve some changes in the DHCP server vendor specific options, but it automates this whole infrastructure to a great deal. Okay. Moving on, section on automation. So as you would know, the OS 6860E today and in future the OS 6860N switches have the application monitoring and visibility functionalities. These application monitoring and visibility functionality works on a 5-tuple where the 5-tuple from an application flow are extracted and they are sent to the signature matching engine, which identifies the actual protocol, which is then we use for monitoring, enforcement, and analytics purpose. Now, in some cases, there is an additional set of attributes which are there in a protocol, which are required for additional analysis by the customers or monitoring purposes, particularly in mission critical networks. An example of which we will see in the following slide. But as a result of this, what we decided to do was to build a framework, an AOS independent framework, which can be used whenever there is a requirement for additional protocol attributes to be extracted from an application flow. Okay. Now, how do we do this? As you would know, the protocol bundle for application monitoring is an independent entity today. It is independent of AOS. It can be built independent of AOS and it can be upgraded on the switches independent of an AOS upgrade. This is done through something called an SDK, and it gives us, once the protocol bundle is built, it gives us a library which we load on the switch and which is used by the application monitoring application on the switch. Now, when the additional attributes for a protocol is required, those attribute slash protocol pair needs to be registered with the signature matching engine. Okay, so this can be done when we are building the protocol bundle kit. So once there is such a request, we can create a new protocol bundle kit, and we can register for the specific protocol attribute pair that is required to be extracted from the flow. Now, in this case, whenever the signature matching engine sees an application flow which matches a top level protocol, it knows that there are some additional attributes that needs to be extracted from this flow. It will communicate that information to the application monitoring task on the AOS, which is generic enough to create a CSV file out of it and dump it in the memory. Now this CSV file is basically what is used today by the Ommni Vista for doing the application analytics and monitoring. So this file can also be extracted by customers to be used for their own analytics. In this case, the additional attributes that they require. We can also display these attributes using a Python-based meta CLI. So all of this has been bundled under appmon data keyword. So a new application name can be defined, and the appmon data, which is a Python-based meta CLI, can actually display it on the screen. All the attributes that were received or all the data that was received with respect to that protocol flow. The only thing we need to be aware of is that since this is a meta CLI, the SNMP MIBs are not supported for this. Also, the signature matching engine does not support the additional attributes to be used for policy enforcement, but they can definitely be used for analytics and further monitoring purposes. This is the use case which initiated the need for developing the framework we developed and we discussed in the previous slide. As some of you would know, SCADA, the Supervisory Control and Data Acquisition Protocol, which is standardized by an IEC standard 60870.5, is used for control in electrical engineering and power system automation applications. The IEC 104 standard, which is a subset of this SCADA standard, defines the message types and the transport of SCADA frames over TCP/IP networks. The communication that is defined by IEC 104 is between a controlling station and a control station in an industrial network setup scenario. It defines the communication by various message types, such as the path activation frames, which have the subtypes as start DT or stop DT, which start and stop a data transfer, and used by controlling station to tell the controlled station when to start or stop a data transmission. It has similar messages which are used on Ethernet protocols, such as the connectivity check frames that we see as Ethernet OAM, where the controlling station and the controlled station send test frame messages to check the connectivity between each other. Similarly, they have measure frames to check the round trip delay and latency among each other. So they are very similar to the current Ethernet protocols that we have today. But the difference here is that this protocol is used for mission critical networks such as electrical substations, where the analysis of these messages being flowing correctly is of utmost important for maintaining a mission critical network such as this. As I described in my last slide, all the commands for displaying the attributes, additional attributes for these protocols have been clubbed under appmon data. The keyword for this protocol is IEC 104. In the meta CLI that we have provided, we have also provided a filter string where you could filter the information coming from the additional attributes to have a more readable format. Moving on, section is hitless upgrades. As we move towards programmability and automation, as I discussed at the beginning of my presentation, we need to be able to manage various components on the fly without requiring an AOS upgrade or a reboot of the system. Okay. For this, we developed a package manager with the goal in mind to be able to start, stop the applications, be able to install or uninstall them, or be able to upgrade the existing applications, and to be able to do so without rebooting the switch as far as possible. Now, it may not be possible in all the cases, but we try to keep that as a goal in mind when we provide this functionality for various things, which we will discuss in a minute. The first use case for this is the security patch upgrade. Now, this relates to the Linux security patch upgrades. Not all the security patch upgrades will be able to do using this mechanism, but yes, we can do some of them on the fly. Only the security patches that are pre-validated by ALE and distributed by ALE through the Ommni Vista or a business portal are allowed through this upgrade method. This allows us to check whether an upgrade can be done on the fly. As you would understand, any upgrade which would relate to a Linux kernel might not be possible to be upgraded in this manner. But any upgrade which can be distributed as a Debian package and be able to apply on the fly will be able to do that using this mechanism. It also allows rollback of packages in case things don't go as planned. In the current release, we will support the OpenSSL and NTP packages to be up for the security patch upgrade to be applied on the fly. The other application that we have is be able to do a dynamic application management. As we saw in the previous slide, we talked about the AOS microservices, which have their own set of applications that need to be launched on the client and broker. Through this framework, we are able to upgrade the whole AMS infrastructure if need be, for example, in case of a bug or adding a functionality without requiring an AOS upgrade. Similarly, as you would see in another presentation, we are coming up with a OVSDB orchestrator. That application is also be possible to install or uninstall or upgrade through this framework. Similarly, any Python scripts that we maintain or we provide to the customers can be installed, uninstalled using this script. Not only that, we provide a mechanism to keep them persistent, which is whenever a system is rebooted, the scripts are reinstalled. This facility also provides maintaining a version of each of these applications or packages. The CLI for this is under package manager command, and install is responsible for installing a package which should come as a Debian package, commit command, and a remove command. The second component is the application manager commands, which we had seen in the AMS slides as well, which can be used for starting or stopping a specific application which falls under the purview of this. That brings me to an end of this section. Hope you like this content. I'll be happy to chat with you during the live Q&A section to hear your comments and answer any questions that you may have. Bye for now. Thank you.